My name is Christian Merkwirth. I'm working for Nauto. Nauto is a startup in Palo Alto in California. So, and the mission of our startup is to improve safety, potentially also efficiency in driving and in transportation. Okay, so we want to make driving, like driving by car or by van or whatever, transportation, we want to make it easier, safer, first of all, and also smarter. Okay, now you can say, well, have a look, autonomous driving is close, right? For sure it is. Like, I saw a lot of the self-driving cars already on the street. But still, the human driving is still the dominating mode of driving, right? And I don't want to give numbers, but I think it will take a couple of years until the fully autonomous driving would be dominant, right? And in this time, even there will be a mixed mode of human and of autonomous driving, which is even more challenging. Okay, driving, transport is something we do every day. So people actually do like billions of miles a year, right? Like not a single person, but the humanity. I don't have actually the number. So we are spending a lot of time on streets. And the death toll of driving is amazingly high. It's like close to 38,000 deaths related to driving and transportation in the US alone. That was 2016. Numbers fluctuate from year to year. It's 1.2 fatalities per 100 million vehicle miles traveled. That is low. In the past, it was much higher. Of course, driving got safer already by a lot of technical means. I don't have the numbers for Poland. It's larger. The number here is higher. It can be road condition. It can be condition of cars. It can be faster driving style. Yeah. And when you break it down, then you can see that actually a lot of collisions are happening because of distracted driving. Okay, distracted driving or distracted drivers, meaning the driver is not paying full attention to driving, right? To the road, to the traffic. So, and it's the norm. It's not the exception, right? People are distracted over the course of driving from A to B. I don't say it's 100%, like I mean, people look on the street, but just, phone, radio, looking around, talking, so people are distracted. And it's simple, right? In this moment, when you are distracted, the probability of collision or of accident goes up, okay? Yeah. So the problem is also that it's not only that the probability of accident goes up, but the accidents are more severe in the moment when you are distracted, right? You might brake late or you might have a higher speed. The impacts might have higher speed. Okay. So what could you do to improve human driving, right? You can assist the driver. So the driver is still in control of the car. But what can you do? You can warn and inform the driver. How? Of course, you need something like computer vision. You need potentially scene understanding. You can monitor. So if you have scene understanding, you can warn the driver if there's an obstacle, if there's a dangerous situation ahead, right? If some pedestrians are walking into the trajectory of the vehicle. The other thing that you can do, that's bad. The other thing that you can do is, of course, to monitor the driver. The state of the driver can be emotional state, can be like sleepiness, drowsiness, it's called. It can be distraction, right? That the driver is not paying attention to the traffic, but it's like texting, using the entertainment system of the car, and the like. There's even more. Like, if you imagine, you go to countries with aging demographics, right? It can happen that people have a blackout in the car. They can have a heart attack. They can have different medical conditions. And it would be good in this moment to warn or potentially even stop the car if possible, right? That would be a bit more than of course, just to warn the driver. Okay, so what did Nauto do in order to improve the driving? So we came up with a device. It's called the Nauto 2 device. I forgot to bring one. That's really bad. You can see the device here on the screen, and you can see the device. It has 2 cameras. You can see this is the windscreen. We are looking from the outside into the car. This is the rear mirror, right? Like the big black thing, right? And here's the device. It's glued to the screen, right? To the window of to the front screen of the car. And you can see below there's a camera looking onto the street, onto the traffic, right? And on the other side, on the top, there's a camera looking into the cabin of the car, right? Okay, here's another like diagram, how it looks like. So basically you can fit it more, it's something you can retrofit to more or less any vehicle, more or less any, there might be some that you can't fit it inside. You see where is this big N logo, this is the place where it's glued to the glass, right, of the screen. It has 2 cameras, one facing to the street, one facing inside of the car. It has, of course, it has a lot of sensors. It has LED and speakers to give feedback to the driver. And it has night vision support, infrared, in case there's not enough light to take picture into the inside of the car, right? Just in the night, right? Or in a tunnel or whatever. And it has LTE connection, to the Nauto backend, okay? So if you have such a device, what can you do with such a device, right? So there are 2 things that you can do. You can put intelligence onto the device. So that means you can do very fast reaction. You can do immediate warning of the driver. But we also, of course, you are limited in some way because the computation capacity on such a device, and that's kind of don't cite me on that. It's kind of smartphone-like technology, smartphone-like chipset, right? It's a bit advanced. So it can stand the heat in a car, which a smartphone can often not. Think about California. Think about places where in summer inside the car the thing is in the full sunlight, right? Smartphones can usually not handle that. So still the computation capacity is limited. So we also connect to the cloud in order to run more advanced models. Okay, let's see it in action, okay? So, you see the 2 views, right? On the left you see the view from the outside facing camera, and on the right you see the view into the cabin, right? And that's actually the founder of Nauto, okay? And let's play it. It's a small video, and you see he's driving by. And you see, okay, now it's a different person. And you see, we have alerting when people get distracted. It's an audio alert, but here just for demonstration, we show it here. You see, red means distracted, right? Distraction often manifests in people looking down, right? Looking on the phone, looking on something. So, and that's a model that runs on device. Okay, that means Nauto is kind of an AI company. We use a lot of AI. We use a lot of computer vision, of course, because the 2 cameras, right? That means a lot of computer vision. We have models that detect distraction, tailgating, meaning to drive too close up front to the driver in front, which, people like to do, also in Poland. Like I said, the device is in some sense compute constrained. It's not super little, but of course it's not as much as you can do in the cloud. And the challenge is to develop tiny models with super high accuracy. And that's of course that's a challenge. I mean, a lot of work is done. Like Google is doing a lot of work. Mobile nets, for example, are especially designed. We also have our own approaches to create models that are small and still very accurate. It's called the student-teacher approach. This is kind of published, but still in detail, if you implement it, it's not that easy. we do, of course, the immediate, the really like live models. They are run on the device, but also we run like higher accuracy models on the Nauto cloud, and we have a dedicated research team. Okay, let's go a little bit into the backend architecture. So, just mentioned in the presentation before, we use microservices, of course, and but we also use stream processing frameworks. Mostly we use Golang, Python, but on device side it's C++, Java. Backend is hosted on AWS. We use a message bus that, like most of you should that's not a really new concept. You should know it. So what happens? The device, of course, talks to the cloud, right? By means of messages, and also like within the cloud, the different components exchange messages. We use both NoSQL and SQL data warehousing on the service side. NoSQL to be really fast. If it's about data warehousing for analytics, it's more like SQL-like stuff. Okay. Let's get a bit more insight. So, for example, the device connects each device, and we are talking about a large number of devices, right? So we sell those devices to fleets. Fleet can be, for example, let's say, what is it like? Like Amazon has a fleet of cars, right? Or transport companies have a fleet of cars. Okay, so actually we have the device deployed in thousands of devices. I don't have the actual number, but it's quite huge, and it's exponentially growing right in the moment, which also means we get really a lot of data. So it's definitely in the order of millions of miles per day, and it's growing. So each device connects every 3 seconds to the cloud, which actually is a lot. We use this kind of status messages to construct trips. Like a trip is when the vehicle is moving. Well, it sounds so easy, but it's actually not so easy to really determine what's a trip. Like a trip from A to B, right? And when we think the car's on the road is moving, we try to identify the driver. I'm coming to this in a second. While a trip is ongoing, the device also will send like events. Events can be heartbreaking, like a collision. It can be turning very, very rough. Of course, the driver is distracted. We will all record this in the cloud. We are a bit bandwidth limited, right? I mean, for cost reasons, technically we could, but for cost reasons we cannot stream the live video from each device continuously, right? If you count that would be like LTE-wise, that would be super expensive. We do. Having said that, we construct the trips, and actually we assign a driver and we assign the events to a trip. We have a dedicated warehousing for analytics and research, and what are the challenges? Well, the challenges is orchestrating devices and cloud side. The problem is a bit that devices are far, right? We cannot reach them. They are not under our control, right? Like they are deployed to fleets, and they are in professionally used cars. So the fleet owner that owns the vehicles, they are not happy to bring that device back, right? The cars where they are installed, they must work so we cannot easily do fixes, bug fixes, right? We have some ways of doing it, but it's not that easy, right? There are strong differences in the usage pattern for different fleets. So it's not really easy to write the code in a way that it fits all of these different fleets. And then there's a problem, different vehicle classes react very differently. You can imagine you have a small car, let's say the Polski Maluch, okay? Which is of course not around anymore. If you have a collision in that car, or you have a collision in a 20-ton truck, it's very differently, right? In the truck, you will hardly have strong accelerations if the truck is not like hitting a concrete whatever wall, right? Like, but a certain collision in a big truck will manifest in a very little signal on sensor side, while in a small car, it's really like drastic, right? And another problem is growth, right? Like we are growing really, really fast. We are exponentially growing in the amount of data we get, and it's a constant race to keep the infrastructure like keeping up with this. Okay. Now I said, when you have a trip, you want to know who's in the car, right? It's not a private car, so we are not necessarily sure who's the driver. It can be like a taxi company or something like this. It can be a rental car, right? So you have different drivers every time. So we do driver identification, and it's crucial to note because in the end we want to know who did the hard braking, who had the collision, right? We know which car has the event, but we do not know like which person has it. So we take snapshots from the inside of the car, and then we run face identification. And actually, that is really large. Like it's a lot of faces. We cannot use the Amazon recognition API because it would be actually too expensive. So we do it in-house. We do like a FaceNet-like model plus Dempster-Schaffer signal fusion. Because we get also other signals, not only the face, we get also other hints who is the driver. So we need to fuse this information to get the identity of the driver. Okay. And also like the snapshot quality inside the car is really, let's say it's really difficult. Because, imagine you have sunlight. So often the sunlight goes, let's say, until here, right? And a part of the face is in shadow, or really, it's changing super fast. So contrasts are super, super large. So when you think that most of the face models that you can find in the net, they are trained on really good images, right? Like at least with a proper lighting condition. And we don't have that, right? We cannot guarantee it. The other thing is that some drivers don't want to be. Drivers sometimes put something in front of the camera, so you get only half of an image. Half. You can see only half of the field of view. So that's really bad. Okay, that's kind of challenging. Yeah. Accidents and collision. Of course, accidents happen. Especially in those fleet cars. These are cars that are not owned by the driver, right? They are owned by some company. And we try to detect, of course, all of these events. Technically, you say events go from S1, severity 1, to S severity 4. Severity 4 is a really strong collision. You will know when this happens, right? S1 means it's maybe just you hit a curb, right? You just hit the side of the road, and it's like, And for example, it's difficult to from the sensor data to do the differentiation between speed bump, right, which you have at different places and people hit it, or you hit a pothole, and it's difficult to draw the line between such an event and hitting the side of the curb, right, the side of the road. When we have a collision, we definitely upload all the data we have on the device. So in this moment, of course, it's an event, and we want to invest the bandwidth. To detect the collision, we use a WaveNet-inspired deep learning model that tells us both the type of a collision and the strength, right? Okay. Now, let's see. We know what happens to the car. We know who's in the car. What can we do, right? We can use all the data and assign it to one driver, okay? And having this data, we can tell something like this: that guy or that woman is driving very smoothly. That person is very attentive, right? Or that person is very often distracted. This person has collisions, right? So we put all that information together and we call it the VIRA score, okay? And the VIRA score is a score between 0 and 100. 100 is really good. 0 is really bad, okay? And it's computed from like acceleration behavior, someone like really like driving very rough, like, accelerating very hard, braking very strongly, cornering like with a lot of G, right? Distraction, tailgating, so someone constantly driving too close up to the car in front. Of course, tailgating is not when you are standing in a queue at the traffic light. That's not tailgating, right? red light running, right? It doesn't happen super often, but if it happens, it's bad, right? It's a strong indicator that the person is not a really good driver. Not technically, but safety-wise, right? So here we see this is an example for an example feed, and here you see the score. It's between like 10 and it's about like between 10 and 100, right? And you see the top performer 16. You see the normal range. Each point is kind of a driver, right? 108 drivers are more or less behaving in a normal range. 49 are below. 12 are kind of really bad. Okay. So, and actually when you have a fleet, when you have a lot of cars and you have drivers employed, it's a nice thing for the fleet manager to see that, right? Because otherwise you don't have a clue who is driving your cars in your vehicles, in which way, okay? And that's of course a web app, so what you can do, now we are showing the movie, we clicked on a driver that is really bad, now we are filtering for events, distraction. We want only really bad distractions, and you get the video, and then have a look. So this is actually data from the website, so that's okay. That's distraction, right? And that's hitting a curb, right? And that happens a lot. You can see where was the car, how fast was the car. Okay, these events are used to calculate the how well a driver is behaving. Now, okay, that is not only about like blaming and shaming. It gives a score, and you can see this score is a time series, right? And actually, you can tell the people, you can tell the driver, that, have a look, you are driving like this, you are doing like that. Please try to be more attentive, right? Please try not to text or not to phone during driving, right? And actually, what happens is that if you look, that the driving style improves over time. So that's actually really an improvement in safety, right? Let me play you this short movie. Okay, now we are looking in the same fleet, sorting it by the score, and looking, for example, for a really good driver. And you see that the score actually improved. Do you see it? From below 50 to about like 87, which is already really good, right? So by giving drivers a feedback about their driving style, it really has an impact, right? It really has an impact on how the driver behaves. I know that now you can say, well, I want to drive like I drive, right? But if you do it professionally, I think it makes sense to give people a feedback so they can improve. Okay? So what are the benefits if you use the Nauto, right? It's improved fleet safety. Drivers, well, it's not only the drivers get aware, but also everyone involved gets more aware of driving style. And it helps the fleet owner, fleet manager to actually coach their drivers. And the funny thing is really that the driving style of most drivers improves over time. Like I don't say everyone gets really super perfect, but in general it improves. And that leads to lower insurance premiums, right? And also the fleet loses, has less losses due to like accidents, due to like insurance claims. Okay, and to give it a number, that's a real number, actually quite recent, like insurance claims go down 35%. Actually, because the people are driving safer, and they have less collisions, and they have less kind of accidents and whatever kind of incidents, even an accident with your own car, right, where no one else is involved. I don't have any numbers on fatalities or something like that. Okay, and my talk is rather short. We are in different lists. We are like among the top the top AI companies, top 100. And I know, sorry, that's cheap. We are hiring. Okay, we have positions in Poland, in Ukraine, and of course in Palo Alto in California. Okay. Yeah, thank you, and questions? So we share it with insurance companies, but there are certain deals. First, I'm technical guy, so I don't know. But those are insurance companies that actually demand their fleet that they insure to have the device installed, and then we give the data. Yeah, but so the question was like if the data can help the insurance company. So from what I know, we work together with several insurance companies. They even ask us to they ask the fleet to have us installed, and then they get automatically a reduced premium. And actually, the insurance companies give us data. So for our analytic pipeline, I think at least with those that we work with, we share data with them. Yeah, but don't quote me on that. Like, ask me. I'm more the neural network guy, so not the business guy. Yeah. In the moment, not, but we are definitely like in this. There's a panic button. I'm not aware if it's triggered automatically, but you can call the panic button will get help, right? So yeah, the idea is actually when you have strong collisions to automatically call 991, right? Basically not call, but send out messages. So in this way, you can even gain several minutes, faster rescue and help in such situations.
Okay, so one more.
Sure.
You mentioned that device connects every 2 seconds.
Yeah.
What about offline mode? It can happen that there's no service.
It can happen, especially in US. The mobile coverage is not that bad, not that good actually when you go outside of the metropolitan areas. The device buffers, right? I mean, we cannot guarantee we cannot guarantee that the device is online. Sure. From what I understood, the Nauto 1 was such an app, but that was way before I joined the company. So I don't have a lot of data on that. The problem with the app is that it's of course possible, and it's kind of the close thing, like put all the intelligence on a smartphone. No installing of a device, no additional hardware. The problem is that smartphones are not that reliable. Also they are not mounted properly. So when you have the G-forces, you don't know too well where is the device. Is it in a pocket? Is it is it in the center of the car? So it's not that easy to do it with smartphones. Yeah. We are deploying an app for the driver, so the driver can see in real time what's going on, so to give immediate feedback. And of course, the device gives you feedback, at least when warning you. So of course, have a look. The problem is, the question was if there's a kind of real-time feedback to the driver. We don't want the driver to have another distraction in the car, right? I mean, it would be really, it would be really it would be against our idea to give the driver more information to digest in the same moment. Drivers should focus on the street. Until there's autonomous cars, drivers should look on the street. That's kind of what we think. Sure.
Because next to safety of driving, gathering such data, awareness, Gs, and so on, there also can be an aspect of economical driving as well, like fuel consumption and so on.
Fuel consumption goes down. So when the Vera score goes up, it includes the harsh, the strong acceleration, strong braking. If a driver is constantly accelerating, braking, fuel consumption is of course much higher, right? So fuel consumption goes actually down in the moment when your score goes up.
Are there any analyses kind of outcome of that observation to
So I think we mentioned this. I'm not the one that goes out into the field to talk to them. I think it is definitely a benefit, but it's a much smaller fraction compared to the insurance, right? So it's good, right? It's good that people use less fuel. They drive more smooth, but the main benefit is, I think, the insurance, because accidents just cost a lot, right?
What about the integration with the smart cars? You have more sensors into the cars.
So we are reading parts of the information from the car sensors, right? Like from the car sensors, and we include that. So it's there's a port in the car that actually delivers it, and actually this port is used to give power to the device.